This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. Thanks for joining me. We're on the second lesson of topic 4, which is 4b, parallel and perpendicular lines. In this lesson, I'll show you how to graph a linear equation on the Ti84 graphing calculator, and we'll also talk in detail about writing equations of parallel and perpendicular lines. You can follow along using this document, and we'll start with that graphing calculator tutorial. Here's a short tutorial on producing graphs on the Ti84 graphing calculator. We'll go over the steps first and then apply it to the example on the right. So step 1, we want to write the equation in slope-intercept form. Notice in the example we have a general form, so we simply solve for y. Press y equals to enter the equation on the Ti84. If you have a fraction in your equation, you could use a fraction button, and I'll show you how to use that. Step 3, press zoom 6 for a standard viewing window. That viewing window is -10 to 10 for the x values and -10 to 10 for the y values. Step 4, press the window button to adjust the window and then press graph after that. If you set a custom window, then press zoom 6. It'll reset to the standard viewing window, so make sure you press graph after you set the window. Let's apply the steps to the example. It says to graph 2x plus 3y minus 6 equals 0. So that's in general form. Our first step is to solve for y, and we can do that by subtracting 2x and adding 6 at the same time. So we get 3y equals -2x plus 6. Then we divide by 3 on both sides, so we get y equals -2/3 x plus 2. Make sure you divide both of those terms by that 3. In step 2, we enter the equation into y equals, but before we do that, I want to give you that shortcut to enter a fraction. Here it is. You press alpha y equals, and then a shortcut menu pops up, and it's the first option, n over d. For this equation, we could do that a few different ways. There are actually 3. The first one is we could enter the negative symbol, then use the fraction button for 2/3. We could also use the fraction shortcut first and enter -2 as the numerator, 3 as the denominator, then arrow right to enter x. Finally, we could use the fraction shortcut first and then enter -2x as the numerator and 3 as the denominator. Okay, now let's go to the Ti84 calculator. If you have a Ti84 graphing calculator, I encourage you to follow along. So I have my calculator on and I am ready to go. One of the first things I'm going to do is press the negative symbol, which is down by the enter button. So we're on step 2, we're entering this equation in. So we press y equals and then the negative symbol. Remember, I gave you 3 options to enter the fraction, alpha y equals, and you can choose whether to include the negative in the numerator or not. And I'm not doing that. I'm just putting the fraction 2/3. Okay, so enter the x variable plus 2, and then after that, we are going to press zoom 6 for standard. So the line gets sketched there, and we have a pretty good window, so we could probably stop there, but I press window, and let's say I want to adjust the window to be -4 to 6 for the x values. We'll just make the window smaller, and -3 to 5 for the y values. Then I press graph. Remember, don't press zoom 6 after you change the window. And then notice we have a nice window. I could press trace to move along the line, and I have the equation up at the top of the screen. And what I'm doing here is I'm trying to find the y-intercept, and I know that it's 2, but how come I can't get it? Well, I press second trace and enter the value, enter 0, and it will show me that the y-intercept is 2. Super! So that makes a lot of sense. It's consistent with what we just did. And once you get a final graph that is looking good, then you stick with that. And you can see what the line looks like, and you can see what the x-intercept, the y-intercept. In this case, the x-intercept is 3, 0. You could see over there to the right. Okay, that's it for the little calculator tutorial. I have some definitions for you regarding the equations of parallel and perpendicular lines. In the previous video, I explained the relationship between parallel and perpendicular lines, but now I have some formal definitions. The first one is two non-vertical lines are parallel if and only if their slopes are equal. And the second one is this: two non-vertical lines are perpendicular if and only if their slopes m sub 1 and m sub 2 are opposite and reciprocal. The phrase if and only if means that the conditional statements work both ways. So if we know that two lines are parallel, then we can conclude that their slopes are equal. Conversely, if we know that the slopes of two lines are equal, then we can conclude that those two lines are parallel. Now we'll apply those definitions to this example. Find the equation of the line through 2, -3 and parallel to 4x plus 5y equals 10. Think about what this example is asking us to do. We have the equation of a line. We need to find the slope of that line, then use it with the given point to find the equation of another line. So let's solve that equation for y. First, we could subtract 4x on both sides, so we get 5y equals 10 minus 4x, or we could write that as -4x plus 10. Then divide by 5 on both sides to get -4/5 x plus 2. That means the slope of that line is m equals -4/5. Now we could write the equation of the line, and we'll use point slope formula for that. So we get y minus -3, because that's the y value, equals -4/5 times x minus 2. And I'll leave the equation in that form because I wasn't asked to solve for y or put it in slope-intercept form. But if I was trying to compare my answer to an answer that's in slope-intercept form, then I would solve for y. By the way, if this example asked us for the perpendicular line as well, or instead, then the slope of that perpendicular line would be positive 5/4, and then we would take the same steps to write the equation of the line. The last example is an application question. The median household income for the United States was $61,423 in 2017 and $61,937 in 2018. The median is a measure of central tendency that represents the middle incomes. Many times it's used to avoid letting the data be skewed by really high values. Okay, let's find a linear model for household income. That means we need to calculate slope and use one of the points to write the equation. So let's find the slope between those two values. And since we're using years, let's let 2017 be x equals 0 and 2018 be x equals 1. The slope between those 2 points is m equals 61,937 minus 61,423, all divided by 1 minus 0. And that's equal to 514. We have our slope, and now we just have to pick a point, and we could use either one. In this case, I chose to use 0, 61,423. So the equation of the line is y minus 61,423 equals 514, quantity x minus 0, but I could just write x. In this case, we want to solve for y because in part B, we'll end up plugging in a number into that equation, and we'll want to know what the y value is. So y is equal to 514x plus 61,423. Now let's use the model to predict household income in 2020. And you know, this example is assuming that the median household income will increase the same amount year over year. Based on that assumption, the household income in 2020 could be found by plugging in 3 into that linear model. So we have y equals 514 times 3 plus 61,423, which is equal to 62,965. Now you could go around asking people what their household income is and compare it to this number. Actually, don't do that. But what you can do is keep your eyes peeled for an example like this in the future, one that involves more data points. We'll use the Ti84 graphing calculator to model that data. That is the end of topic 4. Thank you so much for watching. Next up, we'll look at equations with higher powers. Not special powers, just terms that have higher exponents, like quadratic equations. If you have a question or a comment, be sure to add that below, and I'll see you next time.